All right. 1 second, please. There it is. Okay. Quick question before we begin. Do you see my mouse pointer moving?
Yes.
Okay, very good.
Yes.
Because sometimes it doesn't work. All right, so there's the topic, and I'm going to talk about science versus pseudoscience and the idea of how one can try to debunk pseudoscientific claims. And most importantly, if you're not a scientist and if you're not really working in the field of science, how can you distinguish between what is baloney and what is real interesting thing? So this is a brief outline of my talk, and most likely we will spend about maybe 32 minutes. I timed myself a couple of times. This is usually the average time it takes me to go through all of that. So at the beginning, we'll just define a couple of things that we in science used to call facts, theory, hypothesis, and so on. We'll talk about scientific method. And there are many ways of introducing scientific method. And I find this particular one that was originally stated by Roger Penrose is pretty poetic. So we'll talk about misinformation. How hard is it to debunk a particular myth? And it turns out to be quite a challenge, actually. We'll have quite a few examples of fraud and pseudoscience and physics in related fields. And then at the end, I'll show you this example where instead of talking about a particular personality, we will discuss and try to debunk the idea, okay? And at the very end, of course, there is a conclusion. And since we have, I don't know, a little bit over 10 people, feel free to interrupt me anytime if you have any questions. I'll be more than happy to have a discussion. Okay, so what is science and what is not science? So some terminology first. So when we say word fact in science, we refer to a close agreement between observers about a particular phenomenon. So if you have particular opinion on something and your friend has opinion that is the opposite, you are not talking about the fact, okay? So fact is something that we all agree on. So what is hypothesis? An educated guess, and we'll talk more about these ideas later on, presumed to be factual until supported by experiment. So you hypothesize why a particular thing is happening, and you design a test, experimental test, in order to test whether this hypothesis is correct or not. And most importantly, what distinguishes hypothesis from anything else is the fact that it is scientific if there is a test to prove it wrong. Let me give you an example. Two statements. Number one, material that the moon is made of is complete mystery. Hypothesis number one. Hypothesis number two, the moon is made of blue cheese. So hypothesis number one is not scientific because I cannot design a test in order to check whether it's correct or not. The second example is completely scientific hypothesis, no matter how stupid it may sound. I can just build a rocket and send the rocket to the moon and see whether there is blue cheese there or not, right? So you have to make sure that there is no absolute in the hypothesis. Okay, so what is law principle? Hypothesis that has been tested repeatedly numerous times and has not been contradicted, and then hypothesis is promoted to a law principle. And the final term here is theory. So theory, when we say theory in science, we actually referring to a huge synthesis of a large body of information that encompasses well-tested and verified hypotheses about certain aspects of the natural world. So when we say theory, this is something that has proven to be correct. Okay. All right. So what is science? Very quick statement. A body of objective knowledge and a set of special tools to understand objective reality. So we are talking about something that does not depend on your opinion or opinion of your friend, and so on and so forth. So this is objective reality and a set of tools designed in order to understand and to increase our knowledge on that. So for example, at the very bottom of this page, you see funny cartoon that says this sign is in Spanish when you're not looking. So this is not objective reality, of course. This is something from the realm of humor, right? Okay, so just a very simple exercise on scientific approach. So flashlight doesn't work. What do? Well, you observe that it doesn't work. This is your observation. Then you start questioning why it doesn't work. And then you hypothesize that, well, first of all, it might be dead batteries or burned out bulb. And then you test hypothesis number 1 and number 2. And let's say when you test hypothesis number 1, you replace batteries. And it turns out that this particular exercise didn't really help. Flashlight still doesn't work. So this means that this hypothesis was wrong. So batteries were right. Then you replace burned out bulb, and it turns out indeed that fixed the problem. That's it. So that's the scientific approach. Okay. So we'll try to use this in more general terms several times today. All right. Now, when you talk about these scientific methods, you talk about exciting parts in astrophysics, I don't know, organic chemistry, biology, quantum mechanics. I bet that modern science in any form is a top search if you are to do, I don't know, Bingo search or Yahoo search or Google search. So if you do quantum physics, it gives you about 214 million results, which is pretty good, right? Astrology gives you a little bit more, 259 million results, which is still okay. So some people are just curious about whether 5 planets and the 12 zodiac signs can predict their future. Nothing wrong with that. This one really mind-boggling. So if you type flat Earth, you will have about 545 million results. So people do talk a lot about this. Surprisingly, if you are to go to YouTube, for example, and search for that, you will be surprised how many videos with hundreds of thousands of views on flat Earth. Okay. So what sort of method we need to use in order to understand whether a particular phenomenon is part of science or not? So what is the method we use in science? Now, this is really important aspect, and the best is described by Richard Feynman. So he said, for successful technology, reality must take precedence over public relations, for nature cannot be fooled. In other words, objectivity in science is the key. So I like this poetic approach that describes scientific methods. So this is called shadows of the mind. So imagine that we as human beings live in a tiny small cave where we are born, we spend our time, and then we have kids, and then we die, and so on and so forth. There is no way out. No, you have food, you have water, everything is there. You don't really need to go outside. But then once in a while, you have a person that is born and that person is curious. So that person discovers a tiny small hole in the wall that gives an idea what the world outside might be. Okay. So what you see is shadows of trees outside that you don't really see by yourself. What you see is a bunch of shadows on the walls inside your cave. So how can we approach scientifically this in order to understand what is outside of our cave? So in order to explore the world outside, we would have to do a couple of steps. Step number 1. Well, we first observe. For example, sometimes it is dark in the cave and sometimes we see the light. That's the observation. Okay, this will be fact, right? So everybody agrees on that. Number 2, we question that. We see that this happens periodically and we question why. Why is it that this darkness and light comes out every, I don't know, 10 hours or so, something like that. Then you have to come up with hypotheses. And there is no shortage of hypotheses here, right? Because if you don't really know what outside is going on, you can hypothesize about various things. For instance, there is a huge elephant sitting in there, and the elephant every 10 hours leans against the hole, closing it, right? Well, the first thing you want to do, you want to predict, right? So prediction is in 10 hours, it should be dark again, okay? And then finally, you test your predictions, see whether really Is it dark yet in 10 hours or not? And then, of course, you go back and you try to observe something else that can refine the hypothesis and see, well, what if it's not elephant? How would you know whether it's elephant, I don't know, or huge bear or whatever, and so on and so forth. So that's the example of scientific method. Now, and of course, you have to draw a conclusion, right? So you stop here and then you try to refine your observation, refining hypothesis more and more and more until you reach a state where hypothesis is promoted to law, uh, and so on. Now, brief summary for young folks, okay? So you do the observation first, then you question why you have this particular observation, why you see this particular fact. Then you come up with hypotheses. Remember that your hypothesis could be completely insane, but it must be falsifiable, which means that hypothesis cannot be, this is one of the nature's secrets. That's not a hypothesis. Prediction. Then you have to predict something that you can test experimentally. So you perform the experiment, and then you get the result. More often than not, your result is usually negative. So science is hard work where you try to refine our hypothesis every day, and more often than not, our results are usually negative. So we work and work, and then finally, the final good result is where we see that hypothesis was correct. Okay. So now remember one very important thing. So you cannot be an expert in everything, obviously. I certainly must not an expert in chemistry, for example, or material science or mathematics and so on. But all I remember is if you see extraordinary claim about something, this extraordinary claim must always be supported by extraordinary proof. There is no such a thing as humans can fly with no proof of that at all. Okay, so remember, extraordinary claims demand extraordinary proof. Now, first, really weird example, and it's perfectly scientific, and it gives you sort of a glimpse on how real science may face contradictions. So everybody knows that if you take a piece of magnet, I don't know, buy it at Walmart, for example, for, I don't know, $10, $15, and if you can break it in two pieces, you will have two magnets. If you break each piece into again, you will still have lots of magnets, and each magnet will have pairs of north and south. So no matter how tiny your magnet is, it always has north and south. So you cannot really separate north from south. So you don't have magnetic monopoles. So Paul Dirac in 1931 hypothesized that if magnetic monopole exists, whatever that monopole could look like, this would explain why electric charge in our universe is what is called quantized. So the word quantized is not really scary. In reality, this is what it means. So imagine you take a physical system and you measure total charge of this system, whatever that charge is. I don't know, 25 coulombs, okay? And then you divide this by a charge of a single electron, and you're always going to get an integer number. So you cannot get half of electron. You can't always get 1 trillion electrons, 1 billion electrons, 1 electron, 10 electrons, and so on. This is what calls quantization. So the very idea of a magnetic monopole does not contradict any scientific knowledge. And people realized, well, we have to discover what these monopoles are. So they started measuring different things, and nothing happened. So they couldn't detect anything. Now, this is a funny story. So a professor, very, very famous professor in his field, Blas Cabrera from Stanford University, I believe he's still scientifically active in there, designed an experiment where he used superconductors to measure what is called magnetic flux. So in other words, if a monopole, whatever that monopole could be, passes through this particular device, then this device measures the change of what is called magnetic flux. And by this change, you can say, yes, monopole passed through that, okay? And then he put it in the lab and started measuring that. Nothing happened for a long time. And so these are the measurements on the top. You see something is sort of fluctuating and nothing is going on, and you see these blimps. And these blimps means that some charged particle passed through, so your flux changed to -1 and +1. This means that sort of magnetic pole, north and south, both pass that system. So there is no going up or down. And then all of a sudden, on the 14th of February, and that's why it's called magnetic, I'm sorry, it's called Valentine's monopole. So the 14th of February. In 1982, the impossible happened. So that was the weekend, and nobody was in the lab, as far as I remember when I was reading about this story. So you see this detection. So it seems that monopole passed that device once and never was detected later on. So when Professor Cabrera came back, he was, of course, amazed, but being a scientist, he realizes that you have to repeat that. And then he ran this experiment for another couple of weeks, I believe, or maybe months, and nothing happened. So at this time, science stops and says, well, since there is no contradiction to current knowledge that monopoles should not exist, but we cannot detect them, this means that they are very rare, okay? So that's the example of weird science, but still science. All right, so let's talk about misinformation and how hard is it to debunk a myth. So everybody, once in a while, try to argue on internet. So highly not recommend doing that because there is no satisfaction unless you're talking to good people that are willing to change their minds under the influence of facts, of course, which is really rare and nearly impossible. Well, anyway, so if you see something that is really wrong, you try to debunk that and you try to tell your friends, your family, or your colleagues that, you see, I learned about this and this, and it turns out this is wrong, and that is why this is wrong. And then you're debunking that, okay? So it sounds really easy, right? But it turns out to be really hard, actually. So some examples of fraud before we'll talk about this. So this is probably the champion of scientific fraud, Yoshitaka Fuji, Japanese researcher in anesthesiology, who in 2012 was found to have fabricated data in at least 172 scientific papers. That is just humongous number. So that is the record for the papers by a single author that are required retractions. Okay, fabricated as in published data that were never measured, actually. All right, so everybody knows this guy, Bernametov, right? So he committed a lot of fraud. Now, not everyone knows this story, and that's the sad story, the story about ADE 651. So that's the name of what is called remote bomb detector. A couple of years ago, a particular firm that doesn't exist anymore in the UK was selling these bomb detectors to Middle Eastern countries for obvious reasons, and claiming that this detector, you can actually see that tiny small thingy right over here with antenna, can detect remotely a bomb. Okay, it turns out that if you take this device apart, there is nothing inside, really an empty box with antenna sticking out of it. So this is a dangerous example of fraud, and quite a few people died because of this fraud. So the person who was in charge of selling this is currently in jail, I believe, in the UK. I don't remember his name, and it doesn't really matter. Well, anyway, so that's the example of dangerous fraud. All right, so what are the pros and cons of misinformation and myths? Well, there are quite a few cons, actually. One of them is a very important thing to remember. Misinformation that is merely implied is more difficult to eradicate than misinformation that is stated directly. So there are several, not several, very many examples of psychological experiments research is performed in order to understand this phenomenon. So this is the famous paper by Seifert published in Journal of Experimental Psychology in 1994. So they performed the following experiment. So they had a group of people. And people were exposed to misinformation about the particular warehouse. So of course, the warehouse fire. So there was no fire, obviously, but it was kind of a story. So here's the story. The warehouse was set on fire, and these are the causes, and so on and so forth. So in this story were several correct things and several myths. Okay, so people heard about that, learned, and then after some time, researchers told all the participants that this and this and this particular fact was not actually a fact. And then they tested all participants on whether they remember that several facts turned out to be myths. And some people showed the lingering effect, referring to the misinformation as if this misinformation was actually correct. Now, what are the pros of misinformation and myths? So, and this is obvious. So basically, it's a dictatorship 101. If you can control information and uh, can say anything and people believe in you, so that's the dictatorship 101, right? Make sure people receive as less information as possible, lie as much as possible, so you can control folks around you. So how can we debunk a myth? It turns out that debunking a myth can actually backfire. Backfire as in you really try to say that this myth is a myth and these are the facts, and the person that listens to you, not everyone, but quite a few folks, can actually forget about the facts that you mentioned, but still remember myth, and then later on I'll associate that myth with the reality, which is not the case, of course. So here's the example. Another paper by Schwartz published in Journal of Consumer Research. So to test for this backfire effect, people were shown a flyer that debunked common myths about flu vaccines. So after they were asked to separate the myths from the fact, um, folks scored really nicely. So within the 15 minutes of the end of that. So they had a lot of flyers, and several flyers were showing, well, this is actually a myth and this is correct and so on. And then once retested, all participants scored nicely. So they remember everything was awesome. And then 30 minutes later, they retested them again. And it turns out that several people that were scoring really nicely before actually scored significantly worse, as if for some reason, when they read a flyer which says myth, this, and this, in their mind, that was actually a fact. So debunking can reinforce the myth. Okay? So one has to be really careful with that. All right, so it's very complicated. So how do we approach that? How do we deal with this kind of thing? So the best approach is to concentrate on the facts without well, of course, if you want to debunk a myth, you have to mention what that myth is, right? Of course, but make sure that you mention it as less times as possible and concentrate on the facts. So we'll try to do this at the end, and not probably everyone in this audience knows about the story that I'm going to talk about. So that's a nice example of me trying to debunk something, okay? All right, so examples of fraud and pseudoscience. Well, the first and obvious example with a short story is the story about the astrology, right? So it originated in Mesopotamia many years ago. It claims that it can predict your future based on time of your birth, right? And the place of your birth sometimes. It relies on only 5 planets. We all know that we have actually more than 5 planets in the solar system: the sun, the moon, and 12 zodiac signs. It's interesting that so it originated in Mesopotamia, and then during Dark Ages, during the Church Inquisition, this astrology was completely eradicated. So nobody was actually doing anything about that astrology. So it didn't exist. But then at the beginning of the 20th century, this is first horoscope published in the modern era. So by Richard Naylor's horoscope. So after that, there was a huge explosion of interest in horoscopes and astrology and so on and so forth. Okay, that's kind of interesting. So the UK is to blame for that, by the way. All right. So what is pseudoscience? Well, pseudoscience is the opposite of science, right? So it cannot be tested experimentally in contradiction with well-tested facts. UFO, for example, cannot be tested experimentally. It may be very well the fact that these I don't know, green little men do visit us, but I cannot really predict when that happens, so I cannot measure that. So this is beyond the realm of science at this moment. So I wouldn't call it a pseudoscience because it's not really a science at all, right? So telekinesis, on the other hand, is a perfect example of pseudoscience. So in contradiction with well-tested facts. In a minute, I'll show you a really nice example from former Soviet Union. All right, so another very important thing is pseudoscience is often used to describe scientific theories or data, which, while perhaps legitimate, are believed to be mistakenly used to support an opposing position. I'll show you another example of that. So a wide variety of commercial advertising would also fall into this category. So consumers have to be really, really alert. Okay. So here's a really neat example of telekinesis. I call this example the curious case of Ninel Kulagina. So in early 70s, early 1970s in Soviet Union was a big interest in some weird thingies, right? So there was a big explosion in science, of course, but then was big interest in astrology and telekinesis and so on. So Ninel Kulagina was a really interesting phenomenon. So she approached scientists in one particular research institute and told them that she can move small pieces of matter with her will. So her claim was she could move pieces of matter like matches and so on without direct contact. She claimed that she could stop a heartbeat of a frog by simply looking at it. Moving objects enclosed by glass shield, and so on. So, and of course, you know, not everyone believed her, but then said, well, let me show you. And I'm going to show you a video that I found on the internet, surprisingly still exists. So this is Ninel Kulagina trying to move various pieces of what it seems to be a box, and I think it was like a cigarette and lighter and so on and so forth. You see matches over there, you see this salt thingy, right? And then they're sort of moving a little bit if you can clearly see how it moves, right? And so on. So, and during all these seances, she was doing a lot of screaming and as if she is very concentrated and so on. So now you put this glass shield, right? And then you do this exercise again. Oh, and it's still moving. So there must be something going on and so on. So people were actually doing research on that. And it was shown at the very end that several researchers found a very tiny, small thing, nylon needles that were hidden in her clothes, along with small magnets as well. Okay, so the suspicions rise when most of experiments were performed in uncontrolled environments. So she refused to go to the lab. So they did all these things in motels. And these experiments required long times of preparation on her side where scientists were not present. She called it meditation. So I have to meditate in order to move a couple of pieces of matter. So obviously she was setting this up with magnets and nylon threads and then whatnot. All right, so this one is insanely weird example. And I bet quite a few of you probably heard of airborne, right? So Costco used to carry that. I don't think they still do that anymore. So if you are more interested in more details about this airborne baloney, you could read a really nice piece by Michael Shermer that he wrote in Scientific American about 12 years ago. So you just type airborne baloney in Scientific American and you have this nice example. So let's examine that. So what's wrong with this? So first of all, we read that it's a vitamin, a herbal supplement advertised as a miracle cold buster. You can see a dietary supplement helps support your immune system and so on, fights off colds and builds immune systems and whatnot. So you turn this box on the other side and then you read. The 2003, this is a copy paste, so it's a quote. 2003 trial was a simple, with a small study conducted by for what was then a small company. While it yielded very strong results, we feel that methodology protocol employed is not consistent with our current product usage recommendations. So that should raise a red flag. And they basically telling you, well, in reality, that thing doesn't really work, right? So what is it inside? Well, airborne contains vitamin C. That's a good thing, right? So it may actually shorten the duration of cold symptoms. But the old version of airborne contain 5,000 units of vitamin A and is actually unsafe for some people in doses greater than 10,000 units. This is called hypervitaminosis A. Okay, so one has to be really careful. Now, of course, not everyone has a chemical laboratory back at home, right? And when you shop, you cannot really say whether it's wrong or not wrong. So what are the signs that sort of looking at us and warning us that this is a baloney? And one interesting thing that really striking is if you are to examine the front side of this box. If you read it, it literally says, created by a school teacher. Well, I don't know about you, but I don't want to take any medication that are created by school teachers, no matter how I admire their profession. So I would rather buy something that was actually tested by medical folks, right? So airborne creator, the Knight McDowell Labs, Victoria, Knight McDowell is a school teacher and her husband is a script writer. So instead of hiding their lack of credentials, they boast about them on their webpage. So created by a second grade school teacher. I don't want to buy that. Well, if I buy, I will never take it. All right. Another example, and I don't think a lot of people know about this, you can actually go to USA Today, and it was posted in 2004 at the very end on November 5th. So they published a paper on the fact that Air Force, sponsored by, of course, our taxpayers, taxpayer dollars, wanted to study psychic teleportation, providing grants up to 7.5 millions. So you can actually read that study that actually got some money. They didn't get $7.5 million, but they get about 100K, I think, something like this. So anyway, so here's the front page of this PDF study. If you are to Google that, or whatever search engine you use, you have free access to a PDF file of that, and you can read it. So some dude named Eric W. Davis from Warp Drive Metrics, I never heard of that, published that teleportation physics study for Air Force. Okay, so the text in general, I was so curious, I just opened it and started reading it. In general, does not really provide any misinformation. It looks fine. I discovered that several pieces of this text are copy-paste from graduate textbooks in physics, quantum optics, and so on and so forth. So to an expert, this proposal is nothing but an attempt to get money without actual new scientific content. But you don't have to be an expert to realize this is a baloney if you go all the way down to section number 5, which is almost at the end, which discusses psychokinesis, government conspiracy, secret experiments by China, and of course, Russians. Of course, Russians are to blame every time. So let me show you an example. As for, this is a copy paste from that document that got money from the government. As for the psychic aspect of teleportation, it became known to Dr. Forward. Dr. Forward actually never mentioned anywhere, and myself, along with several colleagues, both inside and outside of the government, that anomalous teleportation has been scientifically investigated and separately documented by DOD. All right, so how credible is this scientist? Well, take a look at this front page, and I do see this, right? I just do the Google Street View. All right. So, I mean, on one hand, it is laughable, right? So when I saw that first, I just started laughing. And then I realized that I really should cry instead of laugh, because a lot of money that could have been actually used to support real science, grants and whatnot, were wasted on all of that. So this is a really sad example. Okay. Now, 2 more examples, and we'll go to the last part of my talk, and then we'll be done. This is the example of a person from former Soviet Union, and so he actually has a PhD in physics. Believe it or not, he's pretty active right now. Gennady Shipov. So Shipov proposed a new theory about torsion fields that don't exist actually, which proves that one can harvest infinite amounts of energy from vacuum. So his approach contains mathematical errors. And I read a lot of, first of all, I read myself his book, not the whole book, but the half of it. And I discovered quite a few algebra mistakes as well. Okay. So this is just amazing example of a person that is con artist. So name Simeon Gendlin. So he managed to become a head of the research laboratory in two institutions without a college diploma. So, and during Soviet period of time, so the 19, I believe, late 60s. So every time he was asked what he was working on, he replied that that was a top secret research and everybody actually was afraid of KGB, so never questioned him. So later on, he got caught and then he was sent to jail for 10 years. And then when Soviet Union collapsed, he immigrated to Israel and then later on moved to the States. I believe now he's about 80 years old and so on, and he's in New Jersey going as Shimon Genlin. So he didn't actually stop at that time, and he was a CEO of infamous Atom Chip Incorporated, which infamously in 2005 said that they built first quantum optical computer as a laptop. And of course, they didn't do anything. Right? So anyway, so he's still alive and well. All right, so here comes the final part, the fancy example. So the fancy example is example where I would try to quickly pitch the idea that I want to debunk. And if you are interested in learning more about this, you may type a keyword in any search engine and just read about that person. I'm not going to mention his name. So the keyword here is called hydrino, Hydrino, hydrino. So a little bit of physics before we can debunk anything, right? So we all know that if you send the light through glass prism, you see nice rainbow. So the rainbow actually, the color, different colors and how bright these colors are is a unique fingerprint of physical component of the source of that white light. So for example, if you have a gas discharge right over here, tube that contains hydrogen, you will have discrete lines. Okay. Now, this is explained by what is called quantum mechanics, and some of you probably heard of the fact that electrons can occupy certain orbits, and depending on which orbit they occupy, depending on element, they jump between the orbits and they emit different colors, right? So this means that different chemical elements have unique fingerprints that are embedded in these emission absorption spectra. So if we are to examine particular light coming from, I don't know, distant star, we can say what the star is made of. That's the whole thing, okay? So from physics class, don't be afraid of all these formulas. The only thing that you need to look at is one very simple equation right over here. So from ISU Quantum Physics 1 that I teach, students learn the following. So there is a particular equation that describes how electron moves near proton. So electron with proton bounded is called hydrogen atom, right? So it allows solutions, physical solutions, that are categorized by what is called quantum numbers. These are a set of integers. So one thing that you have to look at is the following. What is called principal quantum number, that could be anything that is greater than 1, is comprised of two integers. These integers could be 0 or greater than 0 plus 1. So what you look at this equation, you realize n cannot be less than 1 because J and L are never negative. That's it. That's all you need to know. And you don't have to take quantum physics to realize that. So n cannot be less than 1. That's the outcome of the quantum theory that was tested numerous times, gazillions of times. Okay, so here is a hydrogen model. So now you learn that some person says, oh, claim a new model allegedly predicts the existence of new lower energy orbits of hydrogen with n less than 1. So the first thing you do is say, well, I don't think so. Well, maybe there is something to it, that maybe the theory that person proposed sort of contains the model that we just talked about as a limiting case. Well, it turns out not really, but we'll talk more about this. So now let's assume this is correct. Well, if this is correct, what do we know? This means that since the vast majority of hydrogen in the universe and everywhere around us is in the ground state, we can actually harvest nearly infinite amount of energy, making electrons jump down to the new lower energy orbit that they call hydrino, and releasing the energy which we can harvest. So we solve the problem with energy once and for all. Okay, so do we have any problem with that? Well, that's a pretty big statement, right? So if this is just a theory, as in no experiments, then nobody would really care. But the person that was behind that actually claimed that there was experiment. He was able to publish this experiment in a peer-reviewed journal. So when that happened, a lot of people jumped in and started to check, because as you remember, extraordinary claims demand extraordinary evidence. So Professor Radke from Netherlands spent a lot of time reading that theory, and he showed that that theory is inconsistent and has several serious deficiencies, does not actually predict existence of hydrogen states at all, and there is no theoretical support of hydrogen hypothesis. Another paper that was commenting on that, and actually on the experimental side, mentioned that whatever they claimed they saw in the experiment in reality had huge errors. So that could be anything. All right, if that was enough, a group by Konjevich in Serbia actually performed the same experiment. They built exactly the same apparatus. Everything was the same, performed this experiment, and they have not observed any effects at all. So what they saw was what the regular theory actually predicted. So cannot be independently experimentally verified, in contradiction with well-tested facts. So conclusion. Well, you often hear that, oh my God, this is controversy, right? So you have to allow different opinions. Well, misinformation, lies, fiction are not controversies. The major contributor, unfortunately, to modern pseudoscience hysteria or mass media and internet. So a couple of months ago, I was contacted by a small radio station located in Boston. So they were asking me to participate in a round table about astrology. So I asked what that meant. And the lady said that they wanted me to have a discussion with astrologists. So I asked, why do I have to have a discussion with astrologists? Because everybody knows that planets are not affecting our fate. And the lady said, well, we always open-minded and we want to talk about controversy. And of course I declined. So now, but how come that so many educated folks believe in weird things? Right? And this is a really cool thing that I recently discovered when I was talking to a friend of mine. So he mentioned this term that I never heard before. It's called Gell-Mann amnesia. So invented by Michael Crichton. So here is a quick explanation what that phenomenon means. So you open the newspaper to an article on some subject you know very well. For example, I open and I see optics, right? So you read the article and see that the journalist actually has absolutely no understanding of either the facts or the issues. And so you laugh, right? And then the article is so wrong, it actually presents the story backwards, reversing cause and effect. And you understand that this is all wrong. So you read with exasperation or amusement with multiple errors in the story, and then turn the page to a national or international affairs. And then they read another story by probably a friend of these journalists, or maybe by the same journalist. And if the rest of the newspaper was somehow more accurate, right? So first of all, you read a completely incorrect paper, and then right next to that, you read another paper on the subject you're not familiar with and you believe in this, right? So this is called Gell-Mann amnesia, right? So you turn the page and then you forget what you know. So stay skeptical, right? But try to be creative, and most importantly, use scientific method. And remember, this is very, very important. Extraordinary claims must be supported by extraordinary evidence. Thank you very much for your attention, my friend.
Thank you so much. That was very enjoyable. I enjoyed all of your memes too. Let's open it up for Q&A. If you have a question, I will attend the chat box and we'll be happy to ask your question for you, or you can just unmute yourself by clicking the little microphone in the bottom left-hand corner and asking your question directly. So I'll open up the floor now.
I've got a question, Lindsay.
Yes.
Right.
Your talk was very, very, very interesting. It's very good. I think that I'm a retired engineer, and I found over my career that speaking with data is extremely important. And that's just exactly what you said it. You stated it a more elegant way than I do. But have you? You're a scientist. I'm an engineer. Have you explored this concept from the technology of psychology? There's got to be some reason for this because it's so pervasive.
Yes.
I understand if you get somebody to come and look at your washing machine, for example, it's not working, it's doing something a little weird,
Mm-hmm.
and they'll come up and they'll say, well, this is what's wrong, and you need to get this fixed first, and then call me back. Or they'll say, gee, we need to replace the gazinka frats, and they do it and it doesn't work. And I mean, it's just pervasive, and there's got to be more to it than we sort of technical guys
Mm-hmm.
think about it.
Right. That's a very good question. And I'm not the only one thinking about this, of course. There are greater minds. And the champion of that, in my personal opinion, is Professor Michael Shermer from Caltech. So he's a founder of Skeptic Society, and he's a publisher of a Skeptic magazine. I've been reading this for a long time. By the way, ASU has a digital subscription to that. I think you can just go to our library and just download PDF files of that. They have just fascinating articles about different things. But anyway, so he actually published quite a few books, and one of the books that is really interesting and actually goes to exactly to your question is called Why People Believe in Weird Things. So he tries to look at different parts of that from psychology perspective, scientific perspective, and so on. And I don't think he actually has the final easy answer why that happens. But anyway, so he gives an overview of various things. So it's when I was preparing this talk about a year ago or so, I was really fascinated by this experiment with debunking the flu vaccination myths. I was so surprised. So some people show the cognition of hearing myth and bunch of facts and get reading of facts completely, retaining the myth as if myth is a fact. So I was really fascinated by that. And so there is that. And speaking of fixing washer machine, so I was trying to fix my car about a year ago, and I don't know, AC didn't work, so I went to mechanic, and he said you have to replace this and this, 8,000 whatever amount of dollars. So I replaced that because I need a car. Unfortunately, in Arizona, you cannot survive without a car. So it turns out that that was not the cause of a problem. Okay. So, but what can you do? You trust a mechanic, right? The same way as you would trust, I don't know, a physics professor that tells you what are the equations for, I don't know, motion of a planet and something like that. So there is this, you have to be skeptical, but at some point you cannot really do everything by yourself, right? So I had to find a better mechanic. That's the outcome of that. Okay. I don't know if I answered your question or not. So
now it looks like we're all in the same fix.
yes, exactly.
There is
No, that was sorry, that was not 8,000. It was $800, but still pretty big amount. 8,000.
It's never less than $800. Yeah. Just throwing this out there is an ASU unit in the Cronkite School of Journalism and Mass Communication that is looking at the public's trust with news media outlets and trying to understand how news media outlets can remain a trusted source of information instead of being just rejected flat out, regardless of what sort of reputation they have.
Yeah, and so nowadays it's really hard. So I've seen rise and fall of um, really good independent journalism back in Russia at the end of Soviet Union when everything collapsed. That was really good journalism at that time. So people were, they were starving for freedom. And then at that time, it was just absolute. You can open any journal, and I bet these articles were absolute true. So people were trying to find something. But then gradually just declined to whatever that stage is right now. And unfortunately, that's the same thing here in the US as well. So no matter which news outlet you look at, there's always a huge bias. It doesn't really matter what you believe in. It's always huge bias to left, right, and so on. So what I usually do, if you ask me how I approach that, so my morning routine is I'm waking up, make a coffee, and I read headlines only. From left to right, as if I'm reading CNN and Fox News, everything. And then I try to digest all of that. And the truth is usually always in the middle somewhere. Not that I know what the truth is, but then I get a clear picture of the whole playground. Okay.
Other questions?
Mm-hmm. So that's my student, Mohammed. Nice to see you, my friend. So he wrote, in the same example of airborne you used, how does pseudoscience get so far without being debunked to the point that it's sold and end up harming a lot of people? Good question. Well, we have FDA, and that was designed to ensure that that never happens, right? But then we know that in order to get food supplement, I think you don't have to go through FDA approval, right? I believe food supplements and vitamins are not part of that routine, very big scrutiny by FDA. Okay, so that's another example. But then on the other hand, you would say, well, what if we start approving everything? And we don't want to have government controlling everything, but then when we want what we want to have a, sort of a balance, right? Where I don't know. So I don't know, Mohammed, if I answered your question.
You got it. Like I was just asking generally, essentially, like
Yeah.
not
So
just
exactly.
generally.
So basically, so you're taking my class right now, right? I'm teaching you about numerical methods in modern physics, and you're taking my class because you probably trust me, right? And if you don't
Yeah.
really trust me, you can always check my credentials and read papers and whatnot, right? Now, it's really hard to do the same thing over and over again about different pieces of vitamins, right? I don't want to do that. So I would probably move this approval, FDA approval with vitamins there. So that probably will help, I think.
You guys, that makes sense. Thank you.
Dr. Sugaro, can you talk a little bit about, you mentioned this in your car example, this need to trust in more urgent situations. You need your car, so it's, you weigh the risk and just sort of trust your mechanic and pay the money. We've seen this kind of play out in the recent news around vaccines and understanding what it really takes to bring a vaccine to, through the trial process and bring it to market. I mean, it is a very, very painstaking process.
Yes.
And so many people, I think, are beginning to understand what the scientific process actually looks like, and what it has to look like, even despite the demand and despite the urgency. Can you talk a little bit about, whether or not pseudoscience seems to emerge more in those situations of particular urgency?
Good question. So, well, I cannot really say anything professional about vaccination. All I say is that I know vaccination works. Look at the example of polio. So we saved so many lives with that. Now, the process of creating a vaccine is really, really meticulous process. You have to go through different phases and so on and so forth, and it takes a lot of time. Now, I understand the urgency to have the vaccine right now because everybody wants to come back to their regular lives right now, right? So one has to find the balance, and I'm not really sure how to approach that. So I would take this vaccine without even second thought. Okay, so if they ask, "Oh, here is a vaccine, Max. Would you like to take it?" Sure, why not? I actually had COVID in March, so I'm probably partially immune to that. So I would take it with no problem because I do trust and I do trust science. I know it works. Now, if you ask me another question, that is, would you trust Russian vaccine? You probably heard the news, right? So Russia came up with vaccines called Sputnik, right? So I don't know. My answer would be, sure, why not? Well, I survived, I got a lot of vaccines when I was a kid and I'm still, alive and kicking. So I think what they did was to go through military. So basically they did all these fast test steps with vaccine on the poor military guys, right? But they did it and it looks like it probably is working, but there are a bunch of debates going on at the moment. Well, anyway, so if you ask me if I take vaccine, I would say yes, I would. I cannot prove it works, but I think it is working.
It's an example of
yeah, and
I
about
need to trust the
exactly about mechanics is this is the what we call in science iteration process. You start randomly with something, or you ask your friend, who would you recommend, right? Or you ask, I don't know, a friend of friend, and you say, oh, this guy probably is a good one. And then you see if that works. If not, then you iterate to a next mechanic and so on and so forth until you converge. $10,000 later, you converge, right?
Mm-hmm. What other questions do you have in the final moments? We are mindful of your time and want to make sure that we get you back to your busy Friday, but this has been a really fun discussion. So any final questions from the attendees? Nothing in the chat. And if you have a question, make sure to unmute yourself. Greg, I think you're on mute. I see you talking. Do you want me to unmute you? Let's see.
There we go. I got it.
There you go.
In listening to your discussions of several examples, it made me recall some reading I did years ago on the cost of search, Sire and March. And, it's one thing to spend a lot of time and energy validating the expert credentials of a mechanic, and another to validate the efficacy of a vaccine you're going to use in populations of hundreds of millions of people. I wonder how you deal with that yourself. You've kind of touched on it by saying, well, it was only 800. If it was 8,000, I would have done more research. How do you know when to
stop?
Spend more time seeing if it's a myth or just a belief that someone has, or it's got some factual basis?
That's a good question, sir. So in this particular example, I was approached by the actual mechanic that he looked at me and he was saying, this is the amount I have to spend. And I felt that he was scamming me. I could read his facial expression, not because I'm so good at it. It's because people were scamming me for a long time. I'm 46 years old, so I have really good experience with that. So I was able to read it. Okay, but then again, so in terms of credentials in science, it's the same thing. So first of all, it's really hard to enter a new field. So for example, in my case of research, I was trained in one particular field and then I migrated to a new one because of one of the professors with whom I worked several years ago. And it's really hard. And the reason it's hard is because it's not people sort of afraid of newcomers. They want to make sure that you are a good guy, right? As in you could be trusted, so to speak. So this is how science works, right? So, but it takes a lot of time. I believe, and after like 10 years, once in a while, I finally have people inviting me to conferences. So say, oh, Max, I know this guy. He's actually published really good papers now. But it takes a lot of time, unfortunately. Sometimes you don't have time, right? Like your car is broken down, so what do you do?
We see this play out a lot at ASU with the value of interdisciplinary research, where there's a lot of migration of scholars from one discipline to another, working on projects with other scholars. And
so collaboration really helps. So if you do work in the new field, but you find a person that is a star there, so to speak, and that person is interested in working with you, that does help promote your name as people begin to trust you. Right? Trust is a big thing, actually. I don't want to read the thousands of papers that are published every day, but all of these guys, I'm reading just a handful of those. And when I read the paper, I don't want to go through all the details. What I want to learn is what's new, right? So in other words, I'm trusting the process. And I think the person that published a particular experimental results or theoretical results did everything correctly. So I can trust the data and think why this data is this way and not the other way, and so on, right?
Super. All right.
All right.
Final. Thank you so much. This was very fun. It was a pleasure to meet you. And if anybody on this call would like to reach out to Dr. Sukarev in the future, please let me know and I'll shoot you his email. But it's always fun to see Mirabella residents and faculty interact, and we hope to have you back in the future.
All right. Hopefully next time we'll meet in person.
That's the hope. All right.
All right. Thank you.
Take care now.
Thank you very much.
Thanks everyone. Bye-bye.